Hello friends, welcome to Joy of Life. So today we are going to look at a medium level problem from Leetcode. The problem number is 1296. It's a divide array in set of k consecutive numbers. So the description says given an array of integer nums and a positive integer k, find whether it is possible to divide this array into set of k consecutive numbers. Return true if it is possible, otherwise return false. So we are going to look at a couple of examples given over here. So here we see an array that has 1, 2, 3, 3, 4, 4, 5, 6, and we have k as 4. So we have to split this array wherein the numbers are consecutive, right? So if I take this 1, 2, 3, and 4 and put it in one array, so you can see that there are four numbers which are consecutive, and the remaining 3, 4, 5, 6, if we pick them up and we put it like this, then it is also a consecutive, right? So both are of size 4 and k is also 4. So this array can be divided into two arrays of size 4 where the numbers are consecutive. Similarly, you have a bigger number like 3, 2, 1, 2, 3, 4, 3, whatever, and k is 3. So you can see that you can split it like 1, 2, 3, 2, 3, 4, 3, 4, 5, 9, 10, 11, like that. So the important part is the size of this array should be 3 and the number should be continuous, like 1, 2, 3. It should not be 1, 2, 4. It should be the number next to each other, right? So this is the problem all about, and do give it a try. As I always recommend that do give it a try. Try to solve this of your own first, and then you can look at the solution over here. And particularly for this problem, I would like to thank Anish Dubey, who has recommended me to solve this problem. And thanks, Anish, for your support for the channel. I will try my best to capture all the scenarios in this problem for you. So let's move over to the board and let's see how the solution looks. I've taken the same example as we have seen in the Leetcode first example, and we are going to solve this. Here you might see that I have depicted the array into two colors. The yellow color forms one group and the green color forms the next group, right? Where k is equals to 4. So for this particular input, what we'll see is this output, right? 1, 2, 3, 4 being the first group and 3, 4, 5, 6 being the next group. So as recommended by Anish, what I'm going to do is I am going to create this video wherein we'll use a tree map data structure and a queue. Though there is a easy solution which is available using a priority queue as well, but we are not going to look at the solution. Probably I'll make a separate video on that. But this one is definitely much more efficient, and the performance is also much better compared to priority queue algorithm. But here the solution is a little tricky, and we need to understand it in details. So before we do a deep dive of the solution, let's understand what a tree map is. So tree map is a tree wherein the keys are basically sorted according to their natural order. Or what you can do is you can pass a comparator at the time of creation of the map, and it will be and the keys will be sorted based on the same, right? Wherein our queue our queue is a data structure wherein the first element that goes in comes out first. So it's a FIFO data structure. Whereas why we need the tree map is because its ability to sort the keys of the map. So these are the two key elements that we need. So first, what we'll do is we will first create a tree map. So let's create a tree map. And what we are going to do is we are going to iterate over our input array, that is this array over here. And we will store the keys. So keys are nothing but these numbers that you see 1, 2, 3, 3, 4, 4, 5, 5, 6. So for each one of the key, we will store how many times we have seen this element in the array. So 1 we have seen just one time. 2 also we have seen just one time, and similarly we'll fill up the rest of the map. So what will happen at the end of this loop is basically we will have this map created. So that is going to be the first part of our algorithm, right? So let's put it down. What will happen at the end of the first iteration is we will populate the map, right? Where key is the numbers. So these are the numbers, and the value is the frequency, how many times they have occurred. 1 has occurred one time, 2 has occurred one time, 3 and 4 has occurred twice, 5 and 6 has occurred only once, right? And now what we'll do is we will get the key set from this map. So remember over here, the key set will give us the keys in a sorted order, right? So let's say we get the keys into a variable and we want to iterate over this, right? We are going to iterate over this keys that we have got. So keys will give me this numbers, right? This 1, 2, 3, 4. And if I do a get on it, I will get the corresponding values from the map, right? So before we proceed in further into the algorithm, let's understand how our key map is going to help along with the keys that we have got. I have been passed k as 4, right? That means each of the groups should have 4 elements present on it, right? So let's say I start creating my first group over here. And I know that I have 4 placeholders over here. I don't know much, but I just know that there are 4 placeholders. And also at the same time, I know that the first value that will come and sit over here is nothing but the smallest key that is there, right? That's why we have used a tree map so that we get the keys, it will come in a sorted order. So I will get the lowest key over here. So one thing I am pretty sure over here is that my group will start from 1. I don't know I can form the rest of the group or not at this point of time, but I know that this group will begin with a 1, right? And also at the same time, I see that 1 has a frequency of 1, means 1 has been seen only one time. So I know that there will be only one group starting with 1. Had this been, had this count been 2 over here instead of 1, then I would have said that there will be 2 groups that is starting with a 1, right? But there is only one. Okay, that I have started creating a group, right? So I'll say that this is my group in progress. And I know I have started a group. Okay, so what I will do is at the same time, I will maintain in my queue. I'll maintain in my queue because I need to track that at the first key how many group I have started, right? So what I'll be doing is I'll be using a queue in this case. So here I have my queue over here, and what I can say is that for the first key that I have seen, that is, let's put my keys over here for easier understanding. So let's say these are my keys, and my current key that I am dealing with is a 1. For the first key, how many groups I have started creating but didn't ended? I have started creating one group, so I will push that into my queue. But I have started creating it, but I have not finished it, right? Because I know the size is k and I have not reached the size k yet, right? So what I'm going to do is I have to keep a track of the numbers, right? So I will say that let's take a variable over here, last number seen. So before I proceed with my iteration, what I'm going to do is I am going to say that the number that I'm currently at, which is 1, is my last number seen. And I do the iteration. Okay, we'll complete the algorithm part later. First, let us do the dry run, complete the dry run and understand the problem in details. Okay, so this iterates, and now what we get is 1 is done. What we get is a 2. So here essentially I have to check a few things, right? So let's put those conditions over here, that what are the checks that I am going to perform over here. That I have the last seen number, right? So last seen number plus 1 should be equal to my key, current key, which is 2. So you see the last seen number is a 1. I do a plus 1 and I check, is it same as my key? Yes, it is same. That means I am able to continue this group, right? So 2 can easily come and sit over here. Last seen we are checking, and along with that we have to put a AND condition. So if you have a group in progress and your last seen number plus 1 is greater than the key. Let me rephrase this one. So it is better expressed as this. So let's say if 2 is not there and 3 is there. So my last seen number is 1, and the element that the key that I am dealing with is a 3. There are 2 checks over here. So a group is in progress, right? So our one group is in progress, right? And we did not see a 2 and we get a 3. Our key, which is a value which is 3, and our last seen is nothing but 1 plus 1. So 3 is greater than 1 plus 1, right? That means I got a key which is not continuous, right? So in this case, what I should be doing is ideally I should be failing things, right? And say that, okay, I'm not going to continue. Let's proceed with this algorithm over here. We are able to place this 2 properly over here. But can I start a new group at this state? So just think that here I could start a new group, but can I start a new group over here? So how would I identify that I'll be able to start a new group or not in this scenario? So let me first remove this cross sign over here. So what I get from this is a count 1, right? I get a count 1, and I know how many of my groups are open, right? I will subtract group in progress from this. Why I am doing this? Because I know a group is, one of the group has been started which has not ended. and I see there is only one 2. So this two should go to that group, that incomplete group, right? Had there been two twos over here, I could have said that okay, one, two will go to this group, and with the other two, I will start a new group. So that's why what we are doing is whatever count I am getting from this from this key, I am reducing the number of groups that is in progress, right? So what will happen over here is for this index, for this key, which is a two, I know that I cannot start any new group from this. This element can only contribute to a group which is already in progress. Okay, so let's update this value. So I know I cannot update my group in progress, right? Because I cannot change it from 1 to 2, right? It will continue to remain at the same value, right? And what I'll be doing is I'll be updating my last seen number. So the last seen number for me at this stage is a 2, right? And I iterate. Now I get the next key, which is 3, right? So for 3, you see how things are now fall into place. So for 3, what I can say is that uh, my key is a 3. My last scene is a 2. 2 plus 1. So see, this is false, right? False and group in progress greater than 0. Yes, it is. False and a true will keep this into a false state. So it won't go inside to return a false. What it means is basically I can still progress, right? So what I can see is now that I got a 3 and there are two threes over here. So one 3 I can put over here, and with the other 3 I can start a new group, right? So that's what I will do over here. So for this guy, what will happen is what we'll do is 2 minus group in progress, right? And what we'll get is 2 minus 1, right? Group in progress is 1. So I know that I can start a new group over here. So this value will now be updated to 2, right? So I know that at this point, when I saw 1, 1, 1, 2, and 2 threes, I know I can continue my old group, and at the same time, I can start a second group over here. And the second group also will have 4 elements over here. So let me erase this. And what I can say is that I will place a 3 in this group, right? Which is the starting of this group. So what will happen in this queue is what I am going to do is I am going to push a 1, meaning that I have started a group at the key 3, right? And at the same time, last seen number will be updated to 3, and I move on. I get the next key, which is a 4. And again, you see for 4, how things will fall into place. One 4 will go over here, the other 4 will go over here. So you see that over here now what will happen basically is when I do a 2 minus group in progress. So I have 2 group in progress at the moment. So I will get a 2 minus 2, which is a 0, right? So I can say that I cannot start a new group at this position. I can only use it for my existing groups. So that's how these variables are keeping a track of things, right? So now you see what we'll do is our this group is now completed, right? Our first group is now completed. So we'll soon see how things will come into shape over here as well. So what will happen is I'll uh, I'll strike off 4. I'll update the last in number to be 4. When my queue over here has reached the size of 4, or rather when my queue is of the size of k, what we should be doing is we will be reducing the number of open groups. But how do I know how many groups to remove at this position, right? So I have my group in progress and which is currently at 2, but as you can see here, one of the group has ended, right? So with the first k keys, right, one group should end, right? One or more than one group should end, right? I don't know how many groups should end. Had it been a 2, then there should be 2 groups that should have been ending over here. So how would I update this? So I will say, so let's call it GIP with love. So what I'll say is whatever GIP I have, group in progress, I will just do a queue dot poll and remove that many groups. So what will happen? This will get removed, right? this will get removed. And what will happen? This guy will get updated to 1, right? So we are doing a group in progress minus whatever the element I'm getting from the queue. Now see, with 5 in place, what will happen again is I will put the 5 over here, right? And what will happen is now again for this guy, what will happen? It will be a 1. Now my this count is 1, right? We have changed this again back to 1, right? So 1 minus 1, which is a 0. So I am telling him, no, I am not starting a new group over here. And as my size of the queue reaches k again, I will do the same thing again, GIP group in progress minus q dot poll. So what I'll be reducing is a 0 because I know this key has not started a group. So I am just removing those elements, right? So again, when I change this and put 5 and I get a 6 over here, what will happen basically is I'll put the 6 over here. So again, this will be 1 minus group in progress, that is 1, which will be 0. So I know I'm not starting a new group over here, right? So what I'll do is I'll put a 0 over here. Now you see group in progress will do again a group in progress minus q dot poll. So group in progress will come back to 0, right? And we have exhausted all our keys over here. Now when we will definitely complete this algorithm that we have started, but what will be our criteria? When can we say that we have successfully able to divide this? So we will be returning group in progress at the end. When we are done, if my group in progress contains 0, that means no group is in progress, all the groups has been completed successfully as we have done over here. In that case, I can say yes, I was able to put everything back into its place, right? And everything worked fine for me. And so let me clear this board a little up and get the algorithm outside so that we can complete and also see at one of the few of the edge cases that there could be and how we should handle them, right? Okay, so I have got the algorithm over here for you. So let me clear off these variables. And we have a validate condition which is yet to be completed. We have just put the bare minimum over here at the moment. And we are going to see the few variables that we have used over here, how we are going to put that. So validate part we will complete. We'll keep some space for the validate part to complete. And what we are going to do is, let's say we have a queue which is denoted by a Q. So what we are going to do at every step that we did in the dry run is we have added to the queue, right? So we'll do the same, that we'll be adding to the queue. And what we are going to basically add is we have how we have found out the value. We have used the key to get the value, and then we have reduced the group in progress from it, right? So what we are going to do the same thing. So we are going to do a map dot get by the key. We'll get the value so that we get the value over here. And what we are going to subtract is group in progress, grp in progress, right? So this is what we are going to add, and this will give me this values over here. So we are going to continuously for every key, we are going to say that how many groups we have started at this particular key, right? And also we are maintaining a last number scene, so we will have that. So let's say we initialize that with a negative value or something like that, some irrelevant values. And what we'll be doing over here is we will update it. So this number is nothing but my key, right? It is just the value over here, 1, 2, 3, 4, or 5 or 6. This is denoted by the key. So we are going to put that into place. Okay, and also we have to have our group in progress thing properly in place. So that value is nothing but the count of element at that particular key. So if you see over here, I know my group in progress is 1, group in progress is 2. But the moment I have two numbers, that means my group is progress. I'm dealing with multiple groups over here, right? We are going to look at the queue. If my queue size so equals the key that is given to me, right? Key is one of the parameters for our program, that is 4. I'm going to go ahead and update my group in progress, right? So how we are going to do it? We are going to use the same formula. So I'm just putting a shorthand over here, minus equal to, which denotes that you are going to uh, do a group in progress minus q dot poll. So the first element of the queue comes out and we reduce the size by that number, right? And we keep doing this again and again. So we have seen one happy path example where things went fine. And if this condition is ever met, so let me get some space over here because our algorithm is partially incomplete over here. So let me correct the indentation. Just keep in mind this everything that everything that you are seeing over here is inside this iterate of the keys, right? So let me indent it correctly so that it denotes that everything is inside properly, right? And what we are going to do if this validation fails is inside, we are going to say that, okay, return or false. So basically we are checking for the condition wherein things does not go fine, right? So if I am able to come out of this loop ever successfully, so what I'm going to return is, how do I know that it's a valid case or not? We are going to return that group in progress equals 0. So basically, when we are out of this loop, if my group in progress is greater than 0, I am going to say, no, boss, I cannot split this array into like continuous size of k elements, right? I cannot because I have a group in progress which has not ended, right? If it is 0, that means I have completed all the groups the way we have done over here, right? We have completed all the groups successfully, right? And now coming to some, we have already seen one happy path. Now let's see some unhappy paths over here. So far, we have just seen one happy path wherein everything was fitting in perfectly and we did it and we used the tree map and the queue in order to come up with the solution. So there is one part missing to it. So let's complete that part over here. I'm going to cover a scenario wherein I can directly say, okay, no more going ahead. We can stop it directly at this point of time. So let's look at that scenario and let's get that fitted in our algorithm. So we are going to see one such example over here. So let's say I have k, which is 2. So we need to do it for do a group of 2 elements, and we have an input which is like 1, 1, 1, 1, 2, 2, right? So everything is fine. I created the tree map over here. The tree map also looks good to me that we have 1 with the count of 3, we have 2 with a count of 2. So let's create the queue over here and take the variables that we have been using. So let's maintain the last scene. Um, let's have our keys over here. So for the keys, we have a 1 and a 2, right? And we have a queue over here, a miniature version of the queue that we have used. So this is my queue. And what we'll be doing is we'll be start iterating and we'll be getting a key one by one. So we get the first key as 1, right? So we get the first key over here and we see that, okay, everything is fine. And we get a count 3. We deduct the group in progress. Okay, I have 3 groups starting over here. So I put a 3 over here, right? So what that basically means is I have started 3 groups with 1, 1, and 1, right? These are my 3 groups. Perfect. Last scene is basically standing at 1. So I get the next value and everything look good, right? So it is not greater than key plus 2, group in progress is greater than 0, everything is fine. So when I use this key 2 to get the value from the map, what I get is a 2, right? Can I go ahead with the 2? I have 3 groups that I have started. I can put it here and here. What about this? So the bare minimum number of values that I need at any point of time should be greater or equals to the number of group in progress, right? If it is not, I cannot proceed further. I can immediately say that, boss, it's not possible for me to go any further. I am going to return a false right away to you. Okay, so that becomes our third condition over here that we are going to put over here, and that will be with the or condition, right? Because no matter what, I am going to fail it. So if that is true, I am not going to check anything else. It's greater than whatever value that I am getting from the map for the current key. If it is greater than that, then I know that it's not possible for me to continue any further. Okay, so in our happy path, we haven't seen that, right? But when we take an invalid case, that we see that it came to the limelight very fast, right? And it can happen for many of the situation, right? If you have a 1, 2, 2, 1, 2 twos, suddenly 1, 3, then a 4. You cannot proceed any further. So you've started two groups over here, you continued the 2 groups over here, and then you get a single 3. So this will fail if k is 3, right? Not when k is 2. If k is 2, then it's fine. You will have 1, 2, 1, 2, and 3, 4, right? So again, this matters. So that's why we are removing things out of the queue when we reach the desired size. For 1, I'll put a 2 in the queue, right? And for 2, I will put 0 because I haven't started any group over here, right? And the moment the queue size is equals to the size of k, I am going to remove this 2, and I am going to do GIP equals to GIP minus q dot poll, right? Which will reset my GIP to 0, right? So when I get a count of 3 and a value of 1, at that time my group in progress is set to 0. So this will take care of that condition, right? This is how this algorithm works. This is a very simple algorithm, a little tricky, but not difficult. I hope you got the concept behind it. You got the thought process of how every variable over here is playing a crucial role in order to control the output of the function, right? So let's head over to the Leetcode and implement this solution in the code and see how it goes. We're going to check the code over here. So first we'll have a preventive check wherein we can check the length, and we can do a mod with the size k. If it is not 0, we can simply, if it is not 0, we can simply return a false, right? That means we do not have the multiples of k elements over here. So we can just simply say that we are going to return a false. Okay. Otherwise, we are going to create a map, and it is going to have the integer key and the integer values, right? And let's call this a map, and and this should be a tree map implementation, right? And we are going to have a loop over here, and we are going to iterate over the nums, and we are going to populate the map. So we are going to put num, and for each of the num, what we'll do is we'll check in the map. So we'll use get or default, so that even if the key is not present, we can get a default value from there, and we'll default it to 0, and we'll increment it by 1, right? So at this stage, what will happen is our map is now ready. Now we need a couple of variables and the queue. So the queue will store the integer in the queue, and let's call it queue, and let this be a linked list implementation. Oops, sorry. Okay, now the next thing is we need a couple of variables. One is group in progress, okay, which will be initialized to 0, and let's say we have something called a last seen value, which is initialized to -1. Now what we'll do is we'll iterate over the keys, and we will process the key one by one. So, and now once we have the key, the first thing that we'll be doing inside is implementing the checks that we have talked about, right? So the first check is, so let me put it over here. If group in progress is greater than 0, and 2, we need to check the key. Key should be, if key is greater than last seen value plus 1, that means something is wrong, right? We can just stop processing at this point. So basically here we'll be returning a false, right? And along with that, we'll have a or condition wherein we talked about the other condition, right? The edge case condition that we need to ensure. So we will see group in progress. So let me get these conditions down for you guys. If group in progress is greater than map.get of key, the condition that we have already discussed. And then otherwise we need to add to the queue, and we will be doing a map.get by the keys, and we'll be reducing it by group in progress. So that's what we are going to add into group in progress. And for group in progress itself, so once we have updated it, we are going to do a map.get by the key, right? Okay, and we have last seen value that also needs to be updated at every point. So we are going to take care of that. This is nothing but our keys, or the key, sorry. Okay, so now if my queue has reached a size which is equals to the k, then I need to pull things out, and what I'll be doing with that value is I will be reducing the group in progress. Let me get some space. q.poll over here. And when I come out of this loop over here, what we are going to do is we are going to do a return of. So if it is not 0, then I cannot say that it is possible. Let me update this over here. There's a typo here. Good. Let's do a submit and check for the broader range of test cases. Yippee, we are good. So yeah, it has been accepted. It has performance better than 50% of all the submissions. So again, I hope you got the solution over here, how we are using queue and the tree map in order to come up with the solution. So this solution is far better than the priority queue solution, the other solution, but the code is simpler to understand definitely. So I'll try to make a short video on the same. So once again, I hope I was able to clear your doubt, and this goes out to Anish. Anish, I think I was able to clear up the doubts, the thought process behind the algorithm for the same. So you messaged me 10 or 12 days back, but I am not much active on Facebook, so I was not able to get the message. But fortunately, I came across your message, and I hope I was able to clear your doubts. So do let me know what you think about this video. Do give a like if you think this solution is helpful. Before we end this video over here, so let's talk a little about the complexity part of the solution over here. For this part of the algorithm where we are iterating the map, what we are doing is we are iterating over all the n elements in the array, and in the worst case, this is what your runtime is going to be, right? And for space also, you are going to end up creating order of n space you are going to take in your map. So just consider a map having the values like this, where there are no repetitions. So you will end up creating 10 elements inside your map, right? You will have 10 keys with frequency 1, right? And then over here you are starting to iterate over the keys again. So again, I will say that this is going to give you a order of n in the worst case, right? You can have n number of keys where n is the length of the array, and what you are doing is you are putting inside your queue every time you get a key, right? So again, your space is going to be order of n space for the queue, and this is for your iteration, right? So you can see that we are bounded by order of n everywhere, literally everywhere. So yeah, this is a order, this is an algorithm which will have a order of n runtime and order of n space as well. Okay, I know that we are iterating multiple times, so you can say that order of 2n or 3n, but that 2 or 3 doesn't matter, right? What matters is the variable part, the constant part never matters to you. So yeah, that is all from this video. I hope you got the simplicity of the solution. You understand every bit of the code or the solution that we have discussed over here. Do let me know what you think about this video. Do give a like if you think this video was helpful. That will be of great motivation for me as well. Yeah, so that's all from this video. Thanks, Anish, once again for recommending this problem. I think this problem was nice and one of the uh, good problem to be to have in my channel, and to others as well. Do let me know if you want me to solve any problem. Do reach out to me anytime for any problem, may it be from Leetcode or from any other platform or any offline solution, or even any concept related to data structure or algorithm. I am free. I am ready to create the videos for you. So yeah, that's it. See you guys. Have a great day.